All right, so the first thing I'm going to do for you guys is explain all the papers that you're getting. So right here, tests for convergence and divergence. These are going to be our notes for today. So we're going to go through geometric nth term test, and we're going to go through the p-series test today. Now, you also get a sheet that looks like this. It says tests, and it has all of them on there. Now, it's sort of like your cheat sheet of remembering all the different things, because like look, if your R is less than 1, the series is going to converge. If R is greater than 1, the series diverges. Well, look at P series, what we're going to be doing today. You're finding a P, and the P is going to be different. If the P is greater than 1, it's going to converge, which contradicts geometric. So it's kind of hard to memorize. Always good to have this sheet. Now, we will be going through these tests in order, so that will help you with this, okay? Now, the homework. The homework goes along as well as how we're learning them, and I don't have every single thing on there, and sometimes it's because they're just easier and we don't have to do them as often. So you've got geometric, p-series, integral, direct comparison, so on and so forth. Now, whatever we go through that day, that's what you're going to finish. So for example, after today, you're going to do the geometric and the p-series numbers 1 through 6 for homework. I'm going to have some quizzes periodically as we go through this. We'll explain those as well. All right, so today we're going to get started with geometric series test, which is what we did yesterday. So it's a repeat of what we did. Now, up in the boxes, they're going to explain the test to you, and they're going to tell you how it is that you're going to find the information. So as we know from yesterday, if R, your ratio is greater than 1, it means you're multiplying by a number bigger than 1, and so your series numbers are getting bigger, bigger, and bigger, and bigger. So therefore, it's going to diverge. You can't find its sum. Now, if the R was less than 1, meaning you're multiplying by something less than 1, your numbers are getting smaller and smaller and smaller. So you are continuing to add a smaller and smaller number, which means it will converge, and you can find the sum. Okay, and the sum formula is right there. Notice in the homework, I don't ask for the sum, and you won't always be asked for the sum. In our examples here, we will find the sum. All right, so let's take a look. So using the GST, so the geometric series test, determine whether the following series converges or diverges. If it converges, go ahead and find the sum. All right, so the first step is, from what we did yesterday, is find the first 3 terms. Find that first term, and then find that R. So your first term, you're plugging in a 1. Notice down here it says n equals 1. So we plug in a 1, you get 3 over 2 to the 1, which is 3 over 2. Plug in a 2. 3 over 2 squared, be 3 over 4. Plug in a 3. 3 over 2 cubed is 3 over 8. So we find out that our A is 3 over 2, and our R is multiplying. Well, 3 to 3, 3, you're just multiplying by 1. 2 becomes a 4, becomes an 8. You're multiplying all those by 2. So your R is equal to 1/2. Now take a look. The 2 is the only thing that was being raised to the exponent. The 3 wasn't. So the 3 just sort of stayed. So your ratio, the multiplier, was the 2 in the denominator. So 1/2. Now, this R is less than 1, so it will converge, which means we can find our sum. You have your first term divided by 1 minus the R. Now remember to use your calculator. Now, I've already put it in. You get 2 choices. You can do just the alpha y equals and get that fraction, top and bottom. Now look at the first one. I just went ahead and I put it in, 3 divided by 2 over 1 minus 1/2. That's going to be fine. You're going to get your 3 that way. Now the second time was all fancy. I did alpha y equals, and then I did alpha y equals again, and then I did over 1 minus another alpha y equals. You don't have to get fancy in order to get the answer of 3. Okay. All right, let's look at part B. If we look at part B, notice that the whole parentheses is being raised to the n. So when we put in a 1, that's 3 over 2 raised to the 1, which is just 3 over 2. Now when you put in a 2, the whole thing is being squared. So that's 9 over 4. Plug in a 3, the whole thing is being cubed. And then it would just keep on going and going and going. Your first term is 3 over 2. Your ratio, well, look at the top. You're multiplying every time by 3. In the bottom, you're multiplying everything by 2. Also take a look. Your 3 over 2, the entire thing is what's being raised to an exponent. So your r is equal to 3 over 2, which is bigger than 1, which means this one is going to diverge. All right, let's look at this last one. Now be careful. N is equal to 2. Go ahead and hit pause. See if you can figure this one out. All right, so if I plug in a 2, I'm going to go ahead and do it up here. 3 times negative 1/2 raised to the 2. Well, if negative 1/2 is squared, that's going to be a 1/4. 1/4 times 3 is 3/4. Now I'm going to plug in a 3. That's a negative 1/2. So negative 1/2 cubed, that's going to be a negative 1/8. So times a 3, that would be a negative 3/8. Then we're going to do 3 times a negative 1/2 to the 4th. Well, 1/2 to the 4th, that is going to be a positive 1/16. Times a 3, positive 3/16. So on and so forth. Okay? So my first term is 3/4. My r. Now look, it goes positive 3, negative 3, positive 3, and then probably a negative 3, which means it's going to be a negative 1. The bottom, you multiply by 2 every time. So you get a negative 1/2. Look at where it is inside the parentheses being raised to the n. So that's helping you with that negative 1/2 for your r. Now, remember absolute value, that's less than 1. So it's going to converge, which means we can find our sum. So your first term is 3/4 divided by 1 minus a negative 1/2. Your answer should be 1/2 when you put it into the calculator. Right? So again, in your homework tonight for geometric numbers 1, 2, and 3, you do not need to go ahead and find the sum. You just need to let me know what the r is and whether it converges or diverges. All right, let's go ahead and take a look at our nth term test for divergence. Now, nth term test for divergence is actually very easy to perform. Okay? The only thing is, it is only going to tell us one thing. It's only going to tell us if it diverges. It's not going to tell us if it converges, meaning it finds a sum. So these are only going to tell us if we can't find a sum. So if you do the limit as n approaches infinity and it equals anything other than 0, then it's going to diverge. Now think about it. It should make perfect sense. We want to eventually add 0 in order to find a sum. Because if you keep adding a number, it keeps getting bigger and bigger and bigger and bigger. Let's say your limit was 2. Well, that means that it's approaching 2. So every time you're still adding some value of 2. Even if it's 2.0000005, you're still adding the 2. So you need your limit to equal 0 so that eventually you're adding like 0.0000001. So here's the only problem though. This does not say that if the limit equals 0, then it does converge. It's not enough to say that it converges. It says that it doesn't diverge. It just doesn't say, for definite that it does converge. So that's why this test is only partially helpful. It saves us a lot of time if it does diverge, because then if it diverges, we're done. Which is why it says down here, this is a great time saver and always perform it first. Not second, but first. Now, why wouldn't you just do that with all of them? Well, you can't always find a limit. And if you do find a limit and it equals 0, well then you got to go ahead and you got to use another equation or another test anyway. So, let's go ahead and take a look. Now remember, when you're doing limits, as n approaches infinity of any kind of function, you are going to find the answer using Bobo-Botten eats DC. So the only time it's not gonna work is if you have this one. So if it's bigger on top and equals 0, then your test fails. If your test fails, you have to use another test in order to know whether it's going to converge or not. Okay, all of these will diverge. Okay, because bottom, bigger on top, goes to infinity. Well, if it's going to infinity, then you are adding bigger and bigger and bigger numbers. So that's diverging. It's not converging to one number. Eats DC, we just talked about that. If this thing goes to 2, for example, even if it's getting infinitely close to 2, you're still adding 2 every time, which means your series is still getting bigger and bigger and bigger just by a value of 2 every time. So you can't find an actual end sum. The idea is that last number that you're adding has to be 0 or infinitely close to 0, so much so that the decimals don't matter anymore. All right, so let's take a look. So they're going to give you a sigma. For this one, you don't have to write out the first couple of terms because we don't care what the first couple of terms are. We care, what does the limit equal? So you're doing the limit as n approaches infinity, and it's going to be hard to write the letter n. I probably will write x every now and then. I'll try and catch myself. It needs to be an n because we're doing n here. 2n plus 3 over 3n minus 5. Well, this is an eats DC problem. The exponents are the same, so you have 2n over 3n, which is going to equal 2/3. Because it's equaling 2/3, this will diverge. Now again, super easy, okay? You know that this graph is approaching 2/3. Go ahead and graph it in Desmos. So if you graph it in Desmos, you're going to see that it's got a horizontal asymptote at 2/3. Kind of, it looks something like this. And then this right here is 2/3. Now, if we're going from 1 to infinity, so we're adding from 1 to infinity, you're constantly adding 2/3 to a problem. So if you have 2/3 and then you want to add 2/3 to that, and then you want to add 2/3 to that, and then you want to add 2/3 to that, are you getting smaller? Shoot, I just messed it up. You're not getting smaller. You're getting bigger and bigger and bigger and bigger. So every time you add 2/3, your numbers keep getting larger and larger. You can't find a sum if something keeps getting larger and larger and larger. So since you can't find a sum, it's going to diverge. Okay? You would need this to approach 0 so that eventually you were adding 0, not 2/3 every single time. Okay? So it's diverging. Even though it looks like your picture is converging to a number, that number's not 0. So think about diverging, converging. Converging means that you can find a sum because the last number you're adding is 0. Diverging, you can't find a sum because you keep adding something to it. Okay, let's go to B. Now B looks funny with these factorials. Remember that they're explanation marks. N over 2n plus 1. We're not shouting them. It's just that it's factorial. And we'll look at a lot more factorial when we get to the ratio test. But for right now, take a look. You've got n factorial over n factorial. That's another eats DC. They're the same exponent. You do the same thing on the top as you do on the bottom. So you're going to equal 1/2, which means you're also going to diverge. Because if you add 1/2 every time, you're still adding 1/2 each time. So it's getting bigger and bigger and bigger. It's getting bigger slowly, but it's getting bigger and bigger. All right, over here. Again, this one looks weird as well. 3 to the n minus 2 over 3 to the n. But they're the same. 3 to the n over 3 to the n is the same thing. So this is just going to equal 1. It's another different look at eats DC. Since it equals something, again, we're diverging. I didn't want to do a whole bunch of test fails because what good is that going to give us? Okay, we want to see the ones that work. We'll practice it along the way. Don't worry, we're going to do a million of these. All right, let's look at D. All right, D, you got your limit. As n approaches infinity, of 1 over 1 plus 1 to the n. Well, this number is getting bigger and bigger and bigger in the bottom. So that means this thing's going to 0. Okay? 1.1 to the infinity, huge number. You get one slice of pizza and I've cut it into a billion. You're getting not even like a sliver of cheese. You're getting nothing. Now, this means that the test fails. Now, hypothetically, you'd be done. Test fails, boop, can't do anything. However, what if I want to know whether this thing converges or diverges? Well, your test has failed, so you don't know what's going on until you do another test. Now, you might say, well, we only know one test so far. Well, guess what? This one is that test. This one is geometric. How do I know? Well, because look at it. 1 over 1.1 to the n. It kind of looks like, example 1a, 3 over 2 to the n. Look at our ratio is 1 over 2. Okay, we didn't care about the top. We just cared about the thing being raised to the exponent. So this is geometric. I can find my r. My r is going to equal 1 over 1.1. Well, that's smaller than 1, which means this thing is going to converge. So I used another test to determine whether something is converging or diverging. Okay. All right, so let us move on to our p-series test. All right, p-series. A series in the form of 1 over n to the p. Now, you might be thinking, wait, how is that any different from what we just did? Well, look at where your n is. Right here, it's 1.1. Oops, sorry. You can see that. Right here, it's 1 over 1.1 to the n. N is what's in the exponent. For p-series, your n isn't in the exponent. Your n is the actual number. The p is the exponent. Okay? So, you've got 1 over 1 to the p, 1 over 2 to the p, 1 over 3 to the p, 1 over 4 to the p, so on and so forth. It's called the p-series. Where this little exponent here, that's your p. Okay? So let's look at this one. For p equals 1, this series is 1 over n to the 1. Well, so you got 1 plus 1 over 2 to the 1 plus 1 over 3 to the 1 plus 1 over 4 to the 1. Because the n, this number down here, the denominator, is what you're changing. Now, this is a special p-series. This is called the harmonic p-series. You're going to want to memorize that. Even though you've got your notes to tell you stuff, it's kind of like how we memorized the derivative of the square root of x. It's just going to make life a whole lot easier later on. If you know that the harmonic series diverges, then that's going to help you a whole lot. It'll also help you remember what the p's are doing, and it'll help you instead of having to go back and forth between all of your notes. So, let's look at the rules. So, if p equals 1, we just looked at that. That one's called the harmonic series. It is going to be divergent. Now, it will look like 1 over n. You just need to remember that if it's 1 over n, it's divergent. If p is equal to 1, it diverges. Now, if p is greater than 1, so let's say you have, for example, 1 over n to the third, okay? If you have a 1 over n to the third, your p is equal to 3, and this is going to diverge as well. Okay? So if your p is greater than or equal to 1, it's going to diverge. It's just that we separate the p equaling 1 because that is a special harmonic series. We're going to look a little bit more at the harmonic series a little bit later. Okay? Now, if p, this would be less than 1. All right, I'm not redoing my video. You just have to use your eraser. Pretend like we're in class. All right, we come back. Erase, 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 erase. If p is less than 1, so if you had 1 over p to the 1/2, where P is equal to 1/2. That could be a 1/3, 1/4, 1/5, whatever. P is 1/2, then it will diverge. So if P is less than or equal to 1, then it diverges. Okay? Sorry about that. Now, if P is greater than 1, now we can look at our example of 1 over P cubed, where P is equal to 3. And these should be an N. Then it will converge. Okay? So if P is greater than 1, it will converge. If P is less than 1, it will diverge. If P is equal to 1, it's also diverging. Now, it says, note at the bottom, if the P series converges, we cannot find its sum. This is more often the case than not. So a lot of times these P series will converge, but we don't know how to find its sum. So maybe you're happy about that, because then we don't have to. All right, let's take a look at these. Now, I like the P series. P series I think is nice and easy. You just have to make sure you get your greater than and less than, right? But finding the P is nice and easy. Right here, 1 over N. Well, we know that's harmonic. Our P is equal to 1. It's harmonic, which we remember diverges. Okay? So let's look at part B. There's no exponent there. 1 over the square root of N. But can't you make that an exponent? The square root can become an exponent of 1/2. Well, that's exactly like the example I gave you right there with B. So if P is less than 1 and your P is equal to 1/2, it will diverge. All right, let's look at C. Your P, it's right here. Your P is equal to 2. Well, it is greater than 1, so it will converge. Now, meaning hypothetically, you could find a sum. We don't know how to find its sum, but we can. All right, let's look at D. We need to change that to an exponent. The exponents go high, the numbers in the radical go low. So this would be 2/3. So your P is equal to 2/3. 2/3, 2/3 is less than 1, which means it's going to diverge. Go ahead and hit pause. See what you can do with these last ones. Some of these get kind of hard. See what you can do. We'll go over them. All right, for E, a negative exponent. That means it's going to go to the denominator. Now notice, all of our P's have been in the denominator. Okay, your P series, your P is going to be in the denominator. And it's only going to be when that bottom N. So here, our P is equal to 5/3. 5/3 is bigger than 1, which means it converges. We got two things going on right here. So that's 1 over N times N to the 1/2. Well, what would those exponents do? They would add. So what is a 1 plus a 1/2? Well, it's a 3/2. So your P is equal to 3 over 2, which is bigger than 1, so it will converge. Now, look at G. We didn't have any things in the top. We only had things in the bottom. So we need to combine those. This is N to the 1 on the top and N to the 1/2 on the bottom. Well, those subtract. So if you do 1 minus 1/2, that's N to the 1/2 on the top. Well, if I were to take that to the bottom, that would be 1 over N to the negative 1/2. Okay, so P is then equal to a negative 1/2. If P equals negative 1/2, that's smaller than 1, which means this thing is going to diverge. Okay, now let's take a look at this a different way. If I was looking at this, okay, that's the square root of N. If I did the limit as N approaches infinity of the square root of N, that's going to go to infinity. Well, by the nth term test, this thing diverges. So notice that I could use two different tests in order to find the same thing. So the p-series test tells me that I'm diverging, but the nth term test tells me I'm diverging as well. So that's a double test to make sure that we know that this thing is in fact diverging. All right, let's go ahead and find h. All right, so we have n to the 1/2 on the top. We have n to the 1 on the bottom. When we subtract these, we're going to have n to the 1/2 left on the bottom. So your p is equal to 1/2. 1/2 is smaller, so that means it is going to diverge. Now, just out of curiosity though, let's take a look at our limit nth term test. The limit is n approaches infinity of 1 over the square root of n is going to equal 0, where our test fails. And remember when we were doing our nth term test and we said that our test failed, it said that, okay, fine, the test fails means it didn't diverge, but we didn't know whether it converged or not. So we were going to have to do another test. Well, in this case, we were doing the p-series test. And in the p-series test, we find out that it does, in fact, diverge. It doesn't converge. So that just gives you proof that if you're doing the nth term test, it doesn't mean that it automatically converges. You don't know until you do the extra test, whether it be p-series or something else that we'll learn a little bit later. Okay? I know, super confusing, but we'll get there, and as you're going through them, they get a little bit better and better and better. AP Central has some really great videos on these series things, so we'll be watching those as well. As we learn and we kind of get the basics, then we're going to go in and we're going to watch some of those AP videos that will help solidify some of these and how they're going to turn these into a free response question. All right, so you've got some problems for homework. I'm also going to put up a quiz on quizzes. You can do the quiz at this point. It only goes through p-series. So I would make sure that you go through the homework, check it, make sure that you're pretty comfortable with this before you take the quiz. I'll give you 2 chances to go through the quiz. So if you go through the first time and you know, oh, you got something wrong, you can go through it again and try for a better grade. All right, have a great day.